So you guys ready for a test? Not today, but it's coming tomorrow. Find the notes that are posted for today. It looks kind of like that. And this is the part where cell phones need to go away. Need your full attention. Because this one, I think I've mentioned this before, the most important test of this semester. The whole semester. Why? Because other tests go back and reference this stuff over and over again. For example, later on, here's one of the most basic ones. Well, you'll end up in another chapter, and you'll be solving this equation, and it comes down to sine of theta is equal to negative root 3 over 2 at the end of the problem. And then they're like, oh yeah, you just got to use circle trig to find the two answers. So if I were you right now, I'd make a circle, and I'd make an XY axis, and I'd figure out what two quadrants you could be in, and then I would draw pictures with right triangles and figure out, oh yeah, I must be in the 1, 2, square root of 3 triangle, which is the 30, 60, 90, and then figure out what the actual two answers are. They're like 5 pi over 6 and 7 pi over 6 or something like that. It's not it, but okay. I'm going to pause for a second. What I'm trying to say is this same question could come up 2 months from now, and we'll expect you to remember all this circle trig. Draw pictures. So, what if I had said, oh, by the way, and cosine of this angle is also negative? How would that change your two answers? Well, one of them can't exist anymore. Cross off the one that can't exist anymore. And let's see if you have it right now. At first, before I said that, we were looking for the two spots where sine is negative. All of them are positive here, so it couldn't have been here. Sine is positive here, so it couldn't have been there. And now that cosine is negative, then this one's out too. So now I only have to draw one. I know I made you do two because sometimes there are two answers. All right. And sine is opposite of hypotenuse. Here's the opposite side, negative root 3. Here's the hypotenuse side, always positive, remember. And then last but not least, this must be a 1. And then this must be a 60. And then it's not really 60, it's pi over 3. And then this is 3 pi over 3 plus 1 more makes 4 pi over 3. Raise your hand if you had that one right. Okay, questions? Yes? You're correct. It didn't actually matter in this problem because I needed the angle, but you're right. All right. Now, that wasn't many people that had that fully right. So either I'm wrong or there was a lot of issues with this. I'm going to ask one more time. Just be honest. How many of you think it's 4 pi over 3? All right. Oh, well, we're up to about half. Maybe you just weren't raising your hands. All right. Then we should practice that another time. So let's try that again. Cosine of some unknown angle is 1 over root 2. This time I won't mess with you on like cross off one of your answers. Just find the two answers for this. I'll pause for a second while you give that one a try. So here's how you think this one through. First of all, always do this. What's the disadvantage? There's no disadvantage. It helps you. Sometimes you don't need the ASTC, but it's good if you do need it. And in this case, cosine is positive. Look, no negatives. So cosine is positive. So it has to be, I'm going to think of it this way. Here's where it can't be. And in these two, I'll just draw the triangles. So I'm going to draw one like this. And how do I know what the sides are? Cosine adjacent over hypotenuse. And then this must be square root of 3 over here. And now square root of 3 is across from a 60 again, a.k.a. pi over what? Isn't it pi over 3? Oh, no. I must be doing something wrong. Oh, 1 root 2 root 3. That's going to happen to some of you. So I plead with you on this next test. All it takes is something like that. To be like, oh, it's not that one. It's the 1 root 2 test. And you won't even see it. You won't even notice it. So, double check yourself on your triangles. And what's the most common mistake? That is not the most common. What's the most common mistake? Yes? Forgetting negatives. I don't have that issue right this second, but because of the type of question. So this one, it's that, and that's a 45, aka pi over 4. Raise your hand if you had pi over 4. Okay, good. Then we'll go down here and make another triangle. And these I don't even label the sides, because I just go, okay, then it must be a whole bunch of pi over 4s. And I think to myself, that's 4 pi over 4. 5, 6, 7 pi over 4. All right, those are your two answers. What if I said, only in quadrant 4? Well, then you'd have crossed out your first answer, and it would have just gone with the last one. What if I said, cosine has to be positive? Well, wait a minute, we already knew that. Tangent has to be negative. Well, then that would have ruled out the pi over 4 answer, and you would have only had one. All right, I think I've beaten that type of problem to death. Here is one. I'd like you to figure out where 17 pi over 3 is. Like, what the heck are you talking about, Mr. Server? Well, once you find it, I want you to put a line there, and then I want you to find me 3 things that are coterminal to it. So now we figured out where 17 pi over 3 is, and we're finding 2 other ways to say 17 pi over 3 in radians. Check T. Give me one of your answers.
5 pi over 3.
3 pi over 3?
No.
5 pi over 3. He is right. 5 pi over 3. And then how about the negative one? You got that too?
Yep, negative 2 pi over 3.
Oh, so close.
Negative pi over 3.
Yeah, just right there. It's only 1. Pi over 3. Negative pi over 3. Any questions? Do you want to practice that, or is that good? Seeing a few people would like to practice that. All right, let's do one more. Everybody try to find 15 pi over 6. Figure out where that is. And then find me 2 other ways to say it. One of them with a negative angle, and one with a different positive angle in radians. So your first job, figure out where 1 pi over 6 is. And then count it up. Try to figure out where you must be. Okay, so here's how I'd be thinking about this. This is where 1 pi over 6 is, because this is where pi is. And 1/6 of the way to pi is right there. 2, 3, and it's good to kind of get a feeling for how big they are. 4, 5, 6 pi over 6. Now I wouldn't keep counting by ones. So that's 6 pi over 6. Then this is 12 pi over 6. 13, 14, 15 pi over 6 is right there. Now what's another way to say that? I could have said it as pi over 2. What's another way to say that? Negative, use blue here, negative 3 pi over 2s. There's other ways. Any questions about this problem? Yes?
Is there almost like an infinite number or something?
There is. Because you can go around and around and around and around and around, yeah, there's an infinite number of ways to give a right answer. But then weirdly, there's also an infinite number of wrong ways to give the answer too. But, all right. So, last question about this. What is the sine and the cosine of 15 pi over 6? How are you supposed to draw a triangle for that? It's just a line. It's like right here. Remember what to do?
Well, I know sine equals, well, that's gonna equal 1.
Wait a minute. Where's the 1 coming from, though? Not saying you're wrong, just asking. Because somebody's going to be like, how do you get a 1?
Because the unit circle, the radius just gonna be 1.
So you go to the unit circle, and you know the radius is 1. And then this point must be what, comma, what?
0, 1.
0, comma, 1. Excellent. And the sine of it is the y of it, so it's 1. You are correct, sir. How about the cosine?
It's equal to 0.
0. How about the tangent?
1, 1, fine. There's no solution.
How about if I just write it out for you? It's 1 over 0, and you guys should know that that one doesn't exist. No solution. If you graphed it, you'd see you're trying to find tangent of the graph right at an asymptote. There's an asymptote at pi over 2, so. Okay. Cool. What else do you have to know for this test? So many things! Let's shift gears completely. Do you remember going and talking about if I see an ant crawling across the floor at this speed? Let's say he crawls, you know, these tiles here are about a foot, and he does 3 tiles in 15 seconds. I know that's 1 tile per second. That's not what I'm asking. I want to know how fast that is in feet per minute. If you're doing 3 tiles per 15 seconds, then how much is that in feet per minute? Pause for a second. Let me give that one a try. Hint, if you're like, I don't remember this at all. You just got to multiply by facts. And I want seconds to be out of there because they're not in my answers. So I get seconds here, and I think, what's a fact I know about seconds that'll get me closer to this answer? Oh yeah, there's 30 seconds in 1 minute. Anyway, something like that. Pause for a second. I'll give it a try. So you should have been thinking 60 seconds is 1 min, and that's one of the things I wanted is minutes, so that's good. And then a tile is a foot, and now I'm in feet per minute. It's that easy. So this is 180 per 15. Now, would you have to simplify 180 over 15? Yes, you would. You would lose partial credit if you couldn't reduce that. So take a second right now. My advice, break it up. Clearly, 15 is 5 times 3. And then break up the 180 into something, and if it's got a 5 in it, I get the 5 factored out. And if it's got a 3 in it, I get the 3 factored out. Like, let's say you know, thank you, sir, that there's a 3 in it, so you go 3 times 60. Not good enough. I mean, it's a good start. Cancel, cancel. But you couldn't leave it as 60 over 5. So then you go, okay, 5 goes in there. 5 times 10 is 50. So 12. 12 times 5 over 5. I think this is the easy way to do it. You make them factored, and then you cancel them, and then the answer is 12. 12 feet per minute. I better put that in. Raise your hand if you had that one right. Okay, awesome. One more like that, then this is going to be a little harder, though, because it's about rotational motion. Okay? So imagine I have a yo-yo. And so you know how a yo-yo works. You have the yo-yo at the bottom, and then you're holding it like right here. And I can spin it around in a circle. Okay? On the yo-yo string is 3 feet. Now the yo-yo itself, we're just going to be taking a dot here and just saying that dot. I know we could get more picky about exactly how big is the ring around your finger and exactly how wide is the yo-yo, and we're not doing all that. We're just going to say the radius is 3 feet. But if the yo-yo is spinning and I can make it do like 2 rotations per second, then what's its speed in miles per hour? 2 rotations per second. Change that into miles per hour. pause for a sec. Okay, so first off, you got to get rotations off of there. What is a rotation? Well, one rotation is one circumference. So can I just write circumference? No, I got to figure out the circumference. And I know this formula. Circumference is pi times diameter. We would not give that to you. You have to know that. Or circumference is 2 pi r, which is 2 radiuses instead of a diameter. So that works. So 6 pi, don't forget the units. It's all about the units. 6 pi feet. All right. And if this is 6 pi feet, then I've got it down to feet per second now. Is that what I wanted? No. Jacob, what did I want? Miles per hour. I haven't got either unit that I want yet. I got feet per second. Okay, I better get working. I'm going to get the seconds out of there. And I'm going to do something that's kind of complicated. 3,600 seconds is 1 hour. If you didn't know that one, you can use it for free, like I just told you. And if you wanted to, you could have changed that with 2 separate calculations, you know, minutes first and then minutes to hours, but you'd get the 3,600. Okay, and now I'm in feet per hour. I just got to get to miles. You guys remember that unit that I was telling you you'd have to know? 5,000 what? Did you forget? Raise your hand if you know how many it is. It starts with 5,000. Okay, some of you would have been toast. 5,280 feet. And I'm going to put that in the wrong spot by accident. 5,280 feet. How did I know I was in the wrong spot? Isaac, how can I tell that I was in the wrong spot there?
If it doesn't cancel out with the other unit.
Nice, that's a good way to say it. Okay, so this does cancel with the other feet. So now I'm down to, well, I better put what it is, 1 mile. I got miles per hour, but I got to simplify. 2 times 6 times pi, I sometimes forget that, times 3,600, all over 5,280. Gross. Would we have to simplify something like that? Yup. It's part of the job. So then you go, okay, 2 goes into it, right? So I can split this in half. That's not that hard. So that'd be 2,500, and then half of 280 is 140. So then that's 2 times 2,500 and 2,500 plus another 140, 2,640. There we go. And now I changed it to a factored form. And now why is that better? Because look, the 2's will cancel. And you got to keep on going like that. Ooh, I got a good one. Cancel off a 0. That's always good. That's like dividing them both by 10 and factoring the 10 out. And then I would see that they're both even again. And go, all right, well then let's split them both in half. This is 180 times 2 for this 360. And then this 264 is 2 times 132. And wait, canceling the wrong thing. And these 2's cancel. And then I've got a, anyway, I think you get the idea. That's a pain, I know, but it's your job. What I will tell you is if you get the right answer, but you reduce it wrong, I can give you part credit at least if you got the right answer, but reduced it wrong. All right, so let's finish it. The 132 is even again. I'm going to change this into 90 times 2. And then this is 2 times, let me think, 60, 70 is too big, so 65, 66, am I right? Okay, and then this 2 cancels. And now I'm down to 6 pi times 90, 6 times pi times 90 over 66. And ooh, they both have a 6 in them. So then I can take this as 6 times 11. And then I can cancel off my 6's. Oh, I think I finally did it. 90 pi over 11. All right. That's hard enough to be like an R3, isn't it? Okay, so I need a thumbs up. We should practice that more, or a thumbs down. I'm good. Give me a thumbs up or a thumbs down. A lot of thumbs up. All right, we're going to do one more. If I had I guess a classic is a tire. So let's say I'm watching a little kid riding his trike. And on the trike, it's got a little, on these hard tires like you have on a trike, sometimes they get a little like notch in them, like a little cutout spot, and then it makes a thump, thump, thump. And you can hear it, and you're timing it in your head, and you're going, that's about 3 thumps per second. So 3 rotations per second. So 3 rotations per second is how fast the trike's going. You look at the tire and you estimate, looks to me like that whole tire's only like a foot across, the whole thing. Like the diameter is a foot. Then the question is, how many inches is this kid going per second? How many inches per second is the kid going? I'll pause for a sec while you give that one a try. Okay. It's important to know how to set it up. Always set it up like this to start with. Because you got to have a unit on the top and a unit on the bottom. And then you got to fix that to be the units you want. I already have seconds. Sweet. I just got to change rotations. So then I make this 1 rotation so that it cancels rotations. And what is 1 rotation? It is, well, it's a circumference, which is pi times diameter. And the diameter is 1. So that's 1 times pi. And that's in feet, though. And then I got to change it out of feet. So here's a feet on the bottom. 1 foot, 12 inches. Feet cancels feet. And now for the simplify part. 3 times pi times 12. And honestly, I wouldn't multiply that out until I figure out what's on the bottom. Oh, there's nothing to cancel on the bottom. And it's just seconds. 1 second. So then I would multiply it out. I thought I was going to have to cancel something. All right, so if this had been like 180 on the bottom, you would have like tried to factor out a 3 from the 180 and stuff. All right, so this one is pretty simple. So this would be 36 pi, and that's in inches per second. So if you needed to know, like, really what is that? Well, it's about 36 times 3.14. 3.14 isn't as exact, though. Okay, I feel like that's good enough. How many of you would have probably had that one right? All right, then it's time to move on. You need to know 2 formulas about these guys. One of them is that if these are all the same length, you should know something about this. Write down what it is. I'm not even telling you what this length is. I'm telling you they're all the same. If you don't know what theta is, you missed something important. Could you please write out the word and compare it with the kid sitting next to you? All right. A lot of kids do forget this even after I've reminded them, but that's a radian. So that is 1 radian. It's about 59 degrees. Definitely not 60, because if it was 60, then it would take exactly 3 radians to get here. And we all know it's 3.14 radians to get there. All right, so now I'm going to tell you that these sides are 8. Why? Because I want you to tell me the area of that little sector of the circle. You have a formula for that. I'm going to pause for a second. Let me figure out the area of that sector of the circle. If you've forgotten this area formula, I'll remind you. It's a part of pi r squared, which is the whole circle. It's a fractional part of pi r squared. All right, so here's what you should have thought. I need a fraction of pi r squared. And what is that fraction? It's the radians out of 2 pi. If you did not know that, you should write that down, because then you'll improve the chances you remember it. How many radians was it? 1 out of 2 pi. That's the fraction of your circle that you had. Times pi, ooh, the pi's will cancel. Times r, which is 8 squared. You could put this over 1, couldn't you? So then you can see that the pi's will cancel. And then I can go 64 over 2, and that is in, well, it never said what units this was in. Let's say it's in feet. Then this would be in feet. So half of 64 is 32 feet. And then this is an area, so it's actually square feet. Okay. Next one. This little red distance right here, I made it be 8 because, you know, I wanted to make it be a radian. What if I make it not a radian? And I make this be like, I don't know, 7 and 7, and let's say this is a 45-degree angle right here. There's a formula for figuring out how long this arc is. Would you please figure out the arc length? If the radian, or sorry, if it's 45 degrees, and I had a little slip there because I was thinking, they'll need to change that to radians. And the radius is 7. Pausing again. All right, here we go. You should have known this was S equals theta R. S is the arc length. I called it the SARC. All right, that arc length is theta, which is pi over 4. I hope you're getting good at changing these into radians and degrees. If you're not, I'm going to go off and remind you, if I wanted to change that to radians, I'd go 180 on the bottom. Why? So that these degrees would cancel. And then I would have simplified it down, and I'd have figured out, oh, it's pi over 4. So my pi over 4 times 7. 7 pi over 4. Perfectly good answer because there won't be calculators on the test, and that's exact. Raise your hand if you had that one right. Okay, questions? Yes.
Wouldn't that make your arc length in radians? Like, what would that be?
Just because you see a pi there, you think it's radians. And I know people do that all the time. What does pi mean again? 3.14. So it's 7 times 3.14 divided by 4.
Oh, I thought like pi over 4, radians times 7, so that's 7 pi over 4.
I know what you're thinking, but radians don't have a unit. Otherwise, technically, it'd be feet radians. But radians don't have units. I know it's weird, but they don't. So, bottom line, this answer is 21-ish. It's probably more like 22 divided by 4. Will give you the length right here. Yes?
I got the same answer using 45 over 360.
Oh, yeah, that would have totally worked. Yep. Because what is 44 over 360? It's a fraction of the, of what you're doing then is you're trying to find a fraction of the circumference. Okay, so that would totally work. You take the whole circumference and figure out that, and then you say, I want 45 3/60ths of that circumference. That would have worked. If you like that way better, do it. Okay, next kind. Back to circle trig. If you have cosine of some angle equals 2/3, and you're like, what? I don't know any sides that's going to work with. Like, is it the 1, 2 square root of 3 triangle? It turns out it's not. Then they're going to say it's in quadrant 4. Find the, let's see, secant would be too easy. You know why secant would be too easy? Because secant and cosine, you just flips of each other, and I just go, bloop, flip it. Okay, so I'm not going to say secant. I'm going to say cosecant of theta. Okay, so there's another topic of things you have to know. You have to know that for cosecant problems, you really want to go with sine, because sine and cosecant are sister functions, and then flip it. If you don't have these memorized, I'm going to make you a nice little list, and you should copy it. Sine theta goes with cosecant. theta. Cosine theta goes with, anybody know it? Seriously, nobody knows what to put here? Say it if you know it. Secant. And last is tangent. And that goes with what? Cotangent. Being real, you guys are making me nervous. Now, I don't know, maybe it's just because you're quiet and tired, but if you guys didn't know those, you were headed for trouble. We had to spend a whole day where the only new stuff was this. You got to know those, of course. Okay, so back to this. Cosine is positive. Oh, wait, I even know it's in quadrant 4. That means I can right off the bat just rule all these out, and it's got to be here. And cosine is adjacent over hypotenuse. And this is not 1. It's square root of, I like to do it this way, 9 and 4. And is this the longest side? No, that'd be the hypotenuse. So then I minus them. So that's square root of 5. How many of you had square root of 5 on your iPad before I even said it? Okay, good. So square root of 5 is in it, except it's negative. Okay, because it's going down, and it's the most common mistake in circle trig. If you forgot the negative, ouch. Because it'll need that. And now instead of cosecant, I would be figuring out sine of this angle. And then I'd put 1 over it just to remind myself, I got to flip this thing, otherwise I'm going to forget that, and that'll be a big deal. Sine is opposite over hypotenuse, so negative root 5 over 3, but then it's 1 over that. So then that makes me flip it, and that's negative can be either you spot, doesn't matter. Whew, lot to know. Please, be brutally honest. How many of you would have had that right without any coaching from me? That's most of you. Okay. All right, just trying to figure out where we should spend more time. I think we should do another. Well, I'm going to actually put it up for a poll. Do you think we should do more with the sector and like the areas of sectors and the lengths of arcs? Or do you think I should do another one like this? A 1 on your hand, like holding up a 1 or a 2. A 1 on your hand means more like this. And a 2 on your hand means more like this. I'm going to see which one wins. All right. The ones win. Okay. I'll see if I can squeeze in one more of the other kind too. But all right. So let's say I said that the area of a sector was actually make it 9 pi. The area of a sector was 9 pi. The angle was pi over 6. What's the radius? The area of the sector was 9 pi. The angle was pi over 6. Two things that would be critical. One, draw yourself a circle. You know it looks like a sector. Label what you know. Number two, write out an equation that you know. You should know the equation for this. And since I used radians, I would suggest you use the radian version of this area formula. It could be done with degrees, but, and then you could change it all to degrees. It's not illegal. At the end, though, I want an answer in radians, so it seems kind of dumb to change it over to degrees and then back to radians. All right, so here's what I would have been thinking. And I drew my circle kind of funny looking, but the area of that, oh, this angle is pi over 6. That's a really bad pi over 6. That's way too big, so I'm going to make it smaller. All right, so that's pi over 6 right there. And I know a formula for that. Area is the degrees over 360 or the radians over 2 pi times pi r squared. Now I'm going to just write that pure. That's the pure form of that formula. Next, I'm going to actually go use it. Area was 9 pi. Radians was pi over 6 over 2 pi times pi, and then there's r squared. What's r? Well, I don't know. It's the whole point. I'm trying to figure out r squared. So if I can simplify this down, at the end I'll just take the square root and I'll have my answer. But can you handle the algebra? That's why I do the top 20. And some of you that have been hiding your top 20 weakness, instead of fixing it, you could have known that that's a fraction over a fraction, so you can just flip and multiply those. 9 pi stays the same, of course. And this is pi over 6 times 1 over 2 pi. Oh, that's going to cancel really nice. And now I still have my pi times pi r squared here. So 9 pi equals, let's see, there's still a 6 times 2 is 12 on the bottom. And then there's a pi r squared on the top. So now I'm going to divide both sides by pi to get the pi off of there. Dividing by pi is like multiplying by 1 over pi. Cancels, cancels, cancels. 9 equals r squared over 12 times by 12. That's not that hard. I can do this. 108 r squared. What's r? Square root of 108. That almost looks like a hard high school math problem. Like honors pre-calc might be kind of hard sometimes. Yes?
Can you simplify it down to 6?
Oh, it's possible that the square root of 108 could be simplified more. Yep, it is. Now I want to get to the other kids who wanted another one of these. So here's another one of those. Tangent of some angle is 1 over 9. The sine of that angle is negative. What's the cosine of the angle? Don't freak out about the chairs moving upstairs. We have time to do this problem. Probably 5 minutes. So first you should be thinking, where do I draw it? And at first you might have thought that you had two choices. ASTC really helps. Tangent's positive here and here, but sine has to be negative, so it can't be here. Now draw it in the third quadrant. The opposite side is 1, the adjacent side is 9, and I have an apology to make it a negative. I apologize. No, wait, no, I'm right. It's just that they're both negative, which is weird, but true, because do you get they're both negative would cancel and it would become positive? And now I'm really close. Cosine of the angle is adjacent over the hypotenuse, so it's negative 9 over, and this is 81 plus 1 square root of 82. And there you go. Last tip of the day. If you had 2 over square root of 3, don't forget they can do this. 2 root 3 over 3 is the same. This is the same as that. Make sure you study tonight. And that's all I got for you for today.